Good morning, boys and girls. Welcome back. I am Mrs. Allison, and we're going to explore some more together today. The last time we were together, we looked at solids and liquids, and we talked about what makes a solid and what makes a liquid. Let's review that. Solids have a definite shape, like the ball and the Legos. Liquids take on the shape of their container, like the milk in the glass and the soup in the bowl. What season is it right now, boys and girls? That's right, it's winter. And what do we know about the temperature in winter? Winter is cold. It is usually colder than all of the other seasons. In our next couple of lessons together, we are going to look at how science occurs in winter weather. Let's look at today's learning targets. We have 2 learning targets today. The first one says, I can investigate solids and liquids that occur in winter weather. The second one is, I can investigate and measure the temperature of different surfaces in the sun and the shade. Remember, boys and girls, that there are things that scientists and engineers regularly do. And since you guys are becoming curious scientists, we're going to check out that list. Scientists and engineers ask questions and identify problems. They use models. They investigate and observe. They think hard about their observations, and they argue from evidence, research, and talk about their thinking. Here are some questions I have today. These are the things I'm curious about. Why does it only snow when it is cold? And why does snow melt more quickly in some locations rather than others? Let's explore that first question. I have some different materials here today. I have an example of solid water, and I have an example of liquid water. What is solid water called? Yes, ice. So in my container I have ice. What do we know about ice? We have learned that ice has to stay cold in order to remain a solid. Let's look at some pictures of snow. What do you see? I see a few pictures of snow, and then I also see a thermometer. And on that thermometer, the blue is not up very far, and it shows 32 degrees. Did you know that when it snows, it must be 32 degrees or colder for that snow to stay a solid? Otherwise, it will melt and become a liquid. So let's look at the temperature of our liquid water and our solid water here today. I'm going to check my solid water, my ice, first. All right, boys and girls, the temperature of my ice is 27.3 degrees. I'm going to add that to my observation. This is the shape of ice cube I have, so I'm going to put 27 degrees. Now I'm going to check the temperature of the water. The water is 57 degrees. So, what did you observe? Which one is colder? The ice is definitely colder, and look, the temperature is less than that 32-degree freezing point, so that is why our ice is solid. And our water temperature is higher than that 32-degree freezing point, so that is why it is liquid water. So let's look at our question. Why does it only snow when it is cold? Well, we've answered our question. It must be cold for snow, which is the solid form of water, to be frozen. Let's look at our second big question again. Why does snow melt more rapidly in some locations rather than others? All right, we're going to explore and investigate and see if we can answer that question. So I brought some substrates with me today that are going to represent surfaces that we find on the earth. I have a little cup of soil. I have a cup of sand. I have a cup of rocks. And a cup of wood chips or mulch. So I'm going to leave these over here on this side of the table. And then I also have the same materials that are under this scientific tool called a heat lamp. And this is going to be our model of the sun today. So these have been sitting in the sun. All right, I have already drawn on my chart. On this side I have my substrates and I put an X on the sun. These represent the ones not in the sun. And over here I have my sun with a check mark. These represent the objects that are in the sun. So I'm going to first check the temperatures of my substrates that are in the shade or not in the sun. I'm going to start with my soil. All right, my soil is 62.7 degrees, so I'm going to record that on my chart. All right, next I'm going to check my sand. My sand is 60.8 degrees. Next, I will check the rocks. The rocks are 62.7 degrees. And last, I'm going to check the wood chips. The wood chips are 58.4 degrees. Okay, now I need to check the temperatures of my objects that have been sitting in the sun. What do you think we're going to find when I check these temperatures? Let's check them out. I'll start with my soil. Wow, my soil temperature is 96.9 degrees. Next, I'll move to my sand. My sand is also 96 degrees. Next, I'm going to check the rocks. My rocks are 85.6 degrees. Lastly, I'm going to check the wood chips. The wood chips are 70.8 degrees. All right, boys and girls, so take a few minutes to look at those temperatures and think about what you notice and what conclusions you can make. Overall, are the temperatures higher in the shade or are they higher in the sun? Overall, all the temperatures taken of the substrates in the sun are higher. So that must mean that it would be easier for snow to melt in the sun. Now, are there any materials that have higher temperatures than other materials? I notice that in the sun, the soil and the sand have much higher temperatures than the rocks and the wood chips. That might help me to explain why some surfaces melt faster than others when they are covered with snow. All right, so here are some conclusions we can make about our question. Why does snow melt more quickly in some locations rather than others? Well, again, we're going to recap. The items that were in the sun were warmer than the items that were in the shade. So that means that snow will probably melt quicker in the sun than it would in the shade. And then when snow is covering certain materials like soil and sand, then it might melt quicker that way than some of the other materials that it could be covering. Let's look back at our list of things that scientists and engineers do and see if we also engaged in any of these habits today. Did we ask questions and identify problems? We did. We asked 2 questions today. Did we use models? We did. We have our heat lamp. What was that a model of? That was a model of the sun. And we had our model of ice, and we had our water, and we had our different surfaces. Did we investigate and observe? Yes, you guys observed my investigation. Did we think hard about those observations? I know I did, and I bet you did too. Did we argue from evidence, and are we going to talk about our thinking with others? Yes, you guys can share your thinking with someone at home and teach someone else what you learned. Engaging in those habits have helped us to meet our 2 learning targets today. Let's reread those and see if we can shoot our targets. The first one said, I can investigate solids and liquids that occur in winter weather. Well, we talked about how ice occurs in winter weather, ice and snow, and those are both solids for winter weather. The second one says, I can investigate and measure the temperature of different surfaces in the sun and the shade. We did that as well. We have our objects that were in the shade, and we have our objects that were in our model of the sun, and we used our thermometer to investigate those temperatures. All right, boys and girls, that means you guys get to shoot your target. So get your bow and arrow and shoot your target. I am so glad that you guys joined me today to explore these things that occur in winter weather. The next time we're together, we're going to think about the things we learned today, and we're going to see if they can help us to prepare for icy conditions. I hope to see you guys again soon, and keep being curious scientists. Goodbye, boys and girls.